Okay, so I was discussing this particular problem in our AMC 8 live classroom course, and we had a lot of fun with it. There are two ways that we solved this problem, and both of these ways are interesting because they teach you something. If you are following our video lectures or live classroom programs, you already know that I love problem to concept journey. That is, you start with a problem and then you backtrack into the underlying concept and you have a better understanding of what's going on. So this problem says that there is a rectangle which is 4 units wide and 3 units long, and the points C and B are such that this is 1, this is 1, and this is 1. So it's split into 3 equal parts. We are supposed to find the area of this black region. The area of this black region. Now, using this problem, we will learn 2 different ways of thinking about the same thing. And both of them are very instructive. At the end of this video, I'll give you a challenge problem to solve. You can put that in the comment section. If you're interested in the AMC 8 math counts and similar mid-school Olympiad programs, check the link in the description. Alright, so we want to find out the area of these bat wing region, this black region. So first thing, the strategy is take the complement. Complement means find the area of the white region. Find the area of the white region and deduct it from the area of the rectangle. So how do you find the area of the white region? Well, it's quite simple. We have 3 pieces, actually 4 pieces. This one is really easy. Its height is 4 and its base is 1. So it's half into 4 into 1, which is just 2 square centimeters or square units. Similarly, this one is 2 square units. The area of a triangle is half base into height, and the height here is 4 and this base is 1. That's why I use half height times base. Okay, so this is 2, this is 2. The tricky part is to find out the area of this piece and this piece. If we can find this area, these 2 pieces, then we can just delete all of those pieces, all the 4 pieces from the area of the rectangle, and we will find the black region. Okay, so how do we do that? So let's drop a perpendicular from this point here, and let's drop a perpendicular from this point here. So this is just a straight line, and by symmetry we can say that this point is in the middle of AD. It's in the middle of AD. Okay, so this little portion is half. This little portion is half because this total is 1. This is a perpendicular bisector of BC. So this is half, and this entire thing is 1. Okay, now I want to use the first strategy, and this is using similar triangles. So this is strategy 1. This is strategy 1. Use similar triangles. Use similar triangles. So how do you do it? Well, here is the property. Suppose if you have 2 triangles, ABC, and let's say if I draw another line here which is parallel to BC, XY. So I essentially have 2 triangles. The first triangle is triangle AXY, which is this one. And the second triangle is triangle ABC, which is this bigger triangle. Okay? Now, these two triangles are similar. Similar means their sides are proportional. Their sides are proportional. Why is that? What does it even mean? Well, it means that AX over AB is equal to XY over BC is equals to AY over AC. That is the ratio of the sides. One side of the small triangle and one side of the big triangle, if you take the ratios, each of those ratios will be equal to one another. And this is happening because XY is parallel to BC, making this triangle and this triangle similar. Now, it's very important that you understand why parallel lines lead to similar triangles. Unfortunately, I cannot discuss that in this particular video, so I want you to think about it. Why do parallel lines lead to similar triangles? Okay, we discussed this in our AMC 8 program, in the Math Olympiad program that we have. Maybe in some future video I'll talk about that. But this is a very powerful property. So let's look at this. Here we have these two lines parallel. Why are they parallel? Because these two angles are 90 degrees. That is, these two lines are perpendicular to the same line AD. If both of the lines are perpendicular to the same line, then these two lines have to be parallel. Think about that. Both of these lines are perpendicular to the same line. Both of these lines are perpendicular to the same line. So they were moving in the same direction. They are parallel. Okay, this is a very good way of finding parallel lines. If you want to find parallel lines, one way to see it is that, are those two lines perpendicular to some third line? Then they are moving in the same direction. They are parallel. Okay, so therefore, this little triangle and this big triangle are similar. Now notice that this little piece is 1/4 of this big piece. This big piece is 2, right? AB is 1, BC is 1. So this big piece is 2 and this little piece is F. So the big piece and little piece, if you take the ratio, let's call this X, this point as X and this point as Y. So CA over CX is 2 by half, which is 4:1, right? So the big piece is 4 times the little piece. Therefore, XY, the little piece, is 1/4 of this big piece, but the big piece is 4 units. So this little piece is 1. Again, I can write this. That is AF over XY is also 4:1. But AF itself is 4. So XY must be 1. Therefore, what we found is that this is 1. XY is 1. Now BC is also 1. So the area of this little piece is half into 1 into 1, which is just half. I give you the last part of this problem as a challenge. So this is, if this is 1, how much is this one? Can you tell me that? And once you find that out, can you find the area of this triangle, this white triangle? So now, if you can do that, and it's just one line, I'm sure you can, then all the 4 pieces you add them up and delete it from the rectangle, and you will have the bat wing area. Okay, I don't want to do the last line because I want you to do it. If you can, put that in the comment section. I'll give you a strategy 2 of solving this same problem. And there is a lot to learn in this second strategy, though it is not the right way to do this problem. But sometimes you can take the wrong way, or rather the boring way to do a problem, to learn a lot of mathematics. So let's try that. So you have this picture one more time. Let's make it a little bit smaller. So we do learn a little bit of coordinate geometry in AMC 8 program. So what we're going to do is we will use coordinate geometry. So you can imagine that this is your y-axis and this is your x-axis. Okay, and this is the origin. This is a standard strategy. So then this point right here is the origin, which is 0, 0. This one is 3, 0. This one is 3, 4, because you go 3 unit and then you go 4 units. So 3, 4. And this point here is 2, 4, right? Because you just moved back 1 unit. So move to the right 3 units and move back 1 unit. So 2, 4. So now what you can do is you can find the equation of this line. You can find the equation of this line. Similarly, you can find this particular point, which is 1, 4. And you can find the equation of this particular line. And then find the intersection point of these two lines. The coordinate of the intersection points. Okay, so how do you do it? So this is something that we learn in the AMC 8 Math Olympiad program at Cheenta. But if you don't know it, here is the formula. This is the slope formula of a straight line. So what is the formula? You just take a point, let's say 4, 2, 4. Let's say you take this particular point. The formula is y minus y1 by x minus x1 equals to y2 minus y1 divided by x2 minus x1. So why is this true? Again, it's very important to understand why this formula actually works. This side is the slope and this side is the variable slope, and they must be equal. This is the constant slope which you get from the 2 points. So here x1 y1 is 0, 0. x2 y2 is 2, 4. So I can find out the formula equation of the straight line. So this is, let's say I take y minus 0 divided by x minus 0. So x1 is 0 and y1 is 0, right? x1 is 0, y1 is 0 is equal to y2 is 4 minus 0 by 2 minus 0. So 4 by 2, which is 2. So therefore, this is y by x equals to 2, or y equals to 2x. That's the equation of this line. Similarly, you can find the equation of this line. What is the equation of this line? Okay, so you have y minus y1, which is 0. So this is my, now this is my x1 and this is my y1. So y minus y1, this is 0. X minus x1 is 3. And now we have y2 minus y1, which is 4 minus 0. And this is 1 minus 3. So we have y by x minus 3 equals to 4 by negative 2, which is negative 2. So the formula becomes y equals to negative 2 times x minus 3, or y equals to negative 2x plus 6, or y plus 2x equals to 6. So you have two equations, y equal to 2x and y plus 2x equals to 6. You can now solve these two equations to find the value of the intersection point. Once you find the intersection point, you can actually find the this particular height and this particular height, and you can finally do the same thing as we did before. You just delete these two areas. That's the other boring, not correct, not right strategy of doing this problem. But you learn a lot if you treat this as a coordinate geometry exercise. You know, one of the things that you should always try to do is to attempt a problem in different ways. It opens a lot of doors. It makes your understanding so much better. All right. I hope you're doing great problems every day. If you are a Cheenta student, make sure to attend the problem solving classes every day. And I'll see you in the next video. Take care and goodbye.